Hello, everyone. Today we will be presenting our Iowa State University Spring of 2025 Industrial Engineering Senior Design Project. We are Group 5, and this is our final presentation.
I'm Dan Sauer.
I'm Brock Sobaski.
I'm Ian Walworth.
And I'm Sully Woods.
So the problem that we were presented with was a Midwest distribution center that had approximately 300 employees with 3 shifts per day. And in the current state, they were producing 7 pallets per hour, also falling behind on trucks, and had issues with the tower picking system and were working approximately 150 hours of overtime per week. And so the main project objectives that we set were to increase the pallets picked and loaded per hour to around 10, increase the loader value added time to 45%, decrease the weekly overtime hours by 33%, and save a total of $100,000 over the next 3 years.
So we conducted two main forms of research, and the first one was work sampling. And so what we did is we sent 2 of our members to the distribution center where you're assigned, and then 2 to the gold standard within the company, and compared how workers were spending their time. Then next, we did a spaghetti diagram to map how workers were moving throughout the facility. So from this, we saw that within our distribution center, the workers were spending about 61% of their time doing non-value-added work, which was 48.5% higher than the gold standard distribution center. Then from the spaghetti diagram, you can also see that there was a lot of unnecessary movement throughout the facility.
To increase worker value-added utilization as well as decrease total travel distance, our team proposed multiple solutions to the project managerial staff. In our future state design shown on the bottom left is a rough mock-up of the sectioning of the facility into 5 different sections. Within each section, workers will have a more standardized SOP and strict worker ratio utilization, as well as, shown on the right, staging boards for the pallets for the pickers and the loaders to more efficiently stage and load pallets during the process. To test our future state designs, we hosted a Kaizen event at the facility. Originally supposed to take place on April 8th, 2025, we taped out new shadow boards in 10 loading dock areas and was able to collect minimal data, although our testing was a little hampered due to a lack of workers. So we returned to the facility on April 15th to repeat the Kaizen event. And with that, we collected better work sampling data, collected spaghetti diagrams with the new shadow boards in place, as well as collected robust loading data.
Yeah, so with that, we see our Kaizen event results of our loader task breakdown of they were spending almost 32% of their time loading pallets, and then also the other value-added task was wrapping pallets, which is around 10% of the time, which gives them around 41% or 42% of their time doing value-added tasks. This is a significant improvement from their previous task breakdown. And then also on the right, you can see with that sectioning off, the red lines are the loaders, and the loaders are staying much more closely to their designated areas, and they're going picking up their pallets very closely to where they're actually being loaded on that dock. Also, for our qualitative impacts, we see that before the design project, we had around 7 pallets loaded in trucks per hour. And then after the design project, we were seeing around 11.1 pallets loaded in trucks per hour. Also, our loaders did value-added tasks around 29% of the shift before our design and Kaizen event. And during our Kaizen event, we saw loaders did value-added tasks around 41% of the shift, was a significant increase, and then also will help us decrease that overtime because they're getting more pallets out per hour overall. And with that, thank you very much for listening to our senior design final project presentation.